Hey guys, Lissandro here, and today I'm gonna make another question for Quora.com. And today I'm gonna be making a question in regard to heat transfer. Now, some while back I did like kind of a nice brief tutorial in regard to heat transfer and transfer through different mediums like solid, liquid, gas, and vacuum. So I wanted to start with an experiment right here. So let's get a look at it. So let's start off by saying that we have a cylinder. Let's say that this cylinder is red hot and that it is made out of iron. Now this cylinder has an average length of 1 foot and a diameter of 1 foot as well. Now let's say that this red hot cylinder is submerged in water. It's submerged in 1-inch thickness of water all the way around the surface area. Now it isn't just a red hot cylinder submerged in water. That isn't entirely all to it. 6-inch deep into the red hot cylinder is a 1-inch thick rod in diameter that protrudes 1 inch from the red hot cylinder through the water tank, and connected to this rod is a power source. This rod is nothing more than a heat source that maintains the cylinder red hot. Now of course we can't just expect a heavy hot cylinder to float in water, and especially if it's a scorching red hot one. So we have 2 iron blocks, each roughly about 1 cubic inch each, in which the red hot cylinder is resting on. Of course, that's not all to it. It also includes a cooling system. We all know that if you put any red hot metal into water, it'll instantly start to boil the water around it. So that is what happens in the system. The red hot cylinder instantly starts to boil off the surrounding water. The resulting steam then goes through this copper pipe, which is 1 inch in diameter internally, and the walls of the pipe are roughly about 1/4 inch. So the steam goes through this pipeline, which feeds into this radiator-like cooling system. This radiator-like cooling system has an aluminum pipeline which spans 6 feet in length, has an opening of 1/2 inch, and the walls of the pipeline are also roughly 1/4 inch in thickness. So the idea is the steam goes through the pipeline. It then condensates through the cooling system. Then after the steam is condensated through the cooling system, the condensated water is then driven off to a reservoir where all the condensated water is collected. And then a water pump then pumps the collected water back into the system. Now let's say that both the heating element and the cooling system have control dials. The first control dial being for the heating element, which has a range of 100 degrees Fahrenheit to 2000 degrees Fahrenheit. And the second one being the control dial for the cooling system, which has a range of 50 degrees Fahrenheit to -70 degrees Fahrenheit. Now here come the questions. Question number 1. What is the maximum delta T, also known as the temperature difference, that you can have in the system at an ambient temperature of 70 degrees Fahrenheit between the heating element and the cooling system without resulting in any damage or system failure? Now remember, you can alter the temperature of both the heating element and the cooling system. Now, if you choose to raise the temperature of the heating element way too high without adequate cooling, you risk rupturing the containment tank as a result of the excessive amount of pressure produced by the excessive amount of heat, not to mention a backflow through the water pump, damage to the copper pipe as well as the cooling system, and even rupture to the condensation reservoir. As a result, steam just flowing through the cooling system without being adequately cooled. If of course you choose to excessively cool the cooling system, what will happen is that the steam will cool excessively to the point where it does not make it to the reservoir. Instead, the steam condensates within the cooling system and the resulting water freezes within the line, creating a congestion resulting in blockage of the cooling system. As a result, steam will build up within the containment tank and cause ruptures as well as backflow through the water pump. Which brings me to my last question. Question number 2. What are the temperature ranges for both the cooling system and the heating element that you can have simultaneously without resulting in any damage or system failure? So that's pretty much it. So I wish you luck in resolving this problem. But anyway guys, thank you guys for watching. Please like and subscribe and pledge to my Patreon, and I'll catch you guys next time. Bye.